All right. Good morning, A6 Algebra 2 CP. We usually don't see each other on a Thursday, but it is Thursday morning, May 7th. Hopefully you're having a great day so far. Today, what I would like to do, as I just said before we started recording, is I'd like to now shift gears away from the graphical side of rational expressions and functions and equations, and now transition more towards the algebraic side. Before we actually get into solving rational equations, which is the next big idea that we talk about in this class, we are first going to spend just a couple days today and next class on simplifying rational expressions. So just getting comfortable working with fractions and all this type of stuff involving not just numbers. We are going to start with numbers in this little do now that I would like you guys to do while I'm sitting here giving my little intro. Not just with numbers, but also with x's, with variables, with things that require factoring, and so on. All right, so if you want to just take a minute and see if you can get these 4 problems done, that would be really fantastic. I'll give you about 2 minutes to do that until about 10:45 in the morning. In the meantime, let me just give you a couple reminders. So hopefully you should be having a piece of paper out, working on those problems. See if you can remember how to multiply and divide fractions. It may have been a while since you were just asked a straight multiply 2 fractions type of problem and divide 2 fractions type of problem. So hopefully you can recall, but if not, we'll go through it in just a couple minutes. A couple quick reminders. Make sure you fill out the attendance form on Classroom. Your progress assessment on graphing rational functions with holes. It was assigned on Monday. It is due by the end of the day today, as was stated in the email. I've gotten about 50% of them so far, so please make sure you get them done for the deadline. The reason for the Thursday night deadline is so I can grade them on Friday and hopefully get that feedback to you very soon. All right. So please try to get that done on time. If there is some extenuating circumstance that you need to reach out to me and try to work out an alternate plan to get it done, then so be it. We can definitely work through that. But please try to get that assessment done for tonight. Another thing is that today we see each other, and as well as Monday is when we see each other on rational expressions. We're going to spend both of those days talking about rational expressions. Today, we're talking about multiplication and division, and on Monday, talking about addition and subtraction. So it should be fun. After that, we will transition into solving equations once we pick up those skills, just to give you an idea of where we're heading. Other than that, I think we're about ready to get going. I don't think there's any other pressing reminders or news that I have to tell you. So let's go ahead and jump right in. Again, I want to reiterate that if anybody has a question during any of this, because these skills are very crucially important for what we're about to do. So if anybody does have a question, please speak up. Please do not stay silent and just think to yourself, oh, it might make sense a little bit later. Please, please, please speak up and ask, because it's very important that you understand this stuff. If you're a little nervous to speak up, you could always type it in the chat. That's fine. I also want to give a shout out to Miss Mao's Algebra 2 extra help sessions. Not specifically just for Algebra 2, but she does have 2 sections, correct, of Algebra 2 CP. So definitely pop in there. It's every Monday through Thursday from 1:30 to 2. I think I got that right. Did I get that right, Miss Mao?
Yes, you did.
All right, excellent. So please stop by. She also provides notes, which are a great, great resource. So please, please definitely check those out. All right, anyway, jumping right into here. First things first, if I'm going to multiply 2 fractions together, the way that it's done, we don't have to do any common denominators or any complicated stuff like that. That will come with addition and subtraction, but when we're just multiplying, in order to multiply 2 fractions, we just take the numerators and multiply them, and the denominators and multiply them. So all we have to do is 2 times 3 on the top, which is 6, and then in the denominator 5 times 7, which is 35. And so that would simplify to the fraction 6 over 35. Okay? We cannot reduce that fraction. That is what I would then attempt to do. See if there's any common factors. Like, for example, if they're both even numbers, then I can reduce both by a factor of 2. In this case, that's not the case that happens, so we just leave it alone. 6 out of 35. 6/35. Number 2 is the same deal. Numerator 3 times 2 would make 6. In the denominator, 4 times 5 would make 20. We can, however, reduce this one, 6 divided by 20, both of which are divisible by 2, so I can reduce that down to 3/10. See that? Divide both the numerator and the denominator by a factor of 2. Now, so I think multiplying, when you see the refresher, you're probably like, oh yeah, I remember that. That's not so bad. What about dividing? How about if I do 2/5 divided by 7/3? Now, I have to say, even my pre-calculus students, I love them, but they do sometimes struggle with this. They look at a fraction divided by a fraction, and they just like freak out, and they freeze, and they panic, and they don't know what to do. It's when you divide by a fraction, very simply, you just want to multiply by the reciprocal. Okay? So what I want to do when I see that I'm dividing by a fraction is I first want to rewrite this as multiplying by the reciprocal. And again, the reciprocal just means to flip that fraction. So 2/5 divided by 7/3 is equivalent to 2/5 times 3/7. Okay, just want to make that very clear. And if you notice, that's the exact same problem that we ended up with number 1. So 2/3 times 5, or 2/5 times 3/7 rather, is 6 out of 35. Okay? Questions about that? So again, when you divide by a fraction, you don't panic, you don't cry, you don't give up, you just multiply by the reciprocal. The same thing is going on in problem number 4, except it's written in a little bit more of an intimidating way. That looks super complicated. You see a big fraction with a fraction in the numerator, fraction in the denominator. Really though, this is just the same thing as this, written in a scarier way. This is still saying we're doing 3/4 divided by 2/5. So if you want to rewrite it at like this to make it look a little bit more familiar, you absolutely can and should. Now that we're dividing by a fraction, we can just write that as multiplying by the reciprocal. That's 3/4 times the reciprocal of 5/2. And then we would just multiply the numerators, multiply the denominators, we'd get 15/8. And you could leave that as an improper fraction if you get anything like that. You don't have to change that to a mixed number of like 1 7/8 or anything like that. You just leave it as, no, don't change it to a decimal, just leave it as 15/8. Okay? If you feel comfortable doing so, you could also skip from this step up here down to this multiplication step up here, and you could just say, oh, I'm dividing by a fraction, let's multiply by the reciprocal. So if you're comfortable doing that, you can switch, skip this sort of intermediate step. Though I think that's still helpful because you pretty much just pull this complex fraction apart from each other and write it out separately. Does that make sense to everybody how that was done? Very important. Even though they're just regular old numbers right now, there will be x's very soon. Okay? No questions? Okay. I just threw out this term at you called a complex fraction. I just mentioned it when I was talking about problem number 4. And I would like to take just a moment to talk about complex fractions and what they're all about right now, just to show you some basics. So again, if you encounter that situation of a fraction divided by a fraction, we don't freeze and panic and have no idea what to do. Okay? So let's start talking about a complex fraction. I'm actually not a big fan of the name complex fraction. I've also heard them called compound fractions, which I think is a lot more descriptive. When you hear the word complex fraction, you may think that involves complex numbers, being i's and stuff like that. We're absolutely not involving anything like that. A complex fraction, so that's why I don't like the name, because it's a little confusing. Complex usually refers to i's. In this case, that's not what happens. So a complex fraction is simply a rational expression containing one or more fractions. Essentially, it's when you have a fraction, a rational expression, that has fractions in it. Something like problem number 4 is what's called a complex fraction. It's a fraction consisting of fractions. It's like inception, fractionception. So, what we can do with that is the following. Let's take a look at how to explore a bunch of cases involving complex fractions. Suppose that I have a divided by b, some fraction, all divided by c, where a, b, and c are just regular old numbers. I have a fraction, a divided by b in the numerator, and then I'm dividing everything by c in the denominator. Okay? Well, what I can do with an expression like this is, I don't panic again, I can just rewrite it as a over b, the fraction, a over b, and instead of writing divided by c, again, dividing is the same as multiplying by the reciprocal. Think of if you divide something by 2, it's the same as multiplying that same something by 1/2, which is the reciprocal, right? So I could just write this as times 1 over c. right? If you're dividing everything by c, whatever c happens to be, you can do, it's equivalent to multiplying by 1 over c. Divide by 2, same as multiplying by 1/2. When I do this, I multiply just like I did up top, multiply numerators and denominators. This reduces down to a over b times c. Okay? Consider if we had a concrete example. Say I had 2/3 all divided by 5, for instance, just to throw some real numbers in there instead of a, b's, and c's. I could rewrite this now just like up top as 2/3 times 1/5, because dividing by 5 would be the same as multiplying by 1/5. And this would come out to be 2 times 1 in the numerator, 2 over 3 times 5, which is 15. Make sense? Good. What if you have pretty much the opposite? What if you have a fraction in the denominator and another number up top? So what if I have a in the numerator, just some regular old number, and then divided by b over c? So divided by some fraction. Okay, what does that look like? Well, just like I said over here, when you divide by a fraction, you just multiply by the reciprocal. You flip it and multiply. So this would be the same as a, and you could write that as a over 1 if you so desire, because any number can be expressed as over 1, times the reciprocal, c over b. Right? Because if you divide by a fraction, it's the same as multiplying by the reciprocal. Multiply the numerators and denominators, this would come out to be ac over b. Okay? Just again, to show you a concrete example with some numbers, we'll use similar numbers up there. What if I had 5 divided by 2/3? How would that actually simplify? Well, again, you would take that 5, you could write it over 1 if you'd like, and multiply by the reciprocal. Divide by a fraction, same as multiply by the reciprocal. I can't repeat that enough. That's going to be 3 over 2, and it would come out to be the fraction of 15 over 2, which again you could just leave as an improper fraction. You don't have to write 7.5 or 7.5 or anything like that. You just leave it alone. Okay? Last but most certainly not least, what if you have a fraction divided by another fraction, just like in problem number 4? So suppose that I have a over b all divided by c over d, right? Where a, b, c, and d are just any old numbers. What if I have that? What do I do? Well, again, I take this fraction and I multiply by the reciprocal. I'm going to do a over b times the reciprocal d over c, which comes out to be ad over bc. All right? Just to once again show you an example with some regular old numbers. What if I had, I'm going to try to fit it on the bottom of the page here. I should be able to. 5/7 divided by 3/4. You can still see that, right? Got cut off a little bit at the bottom there. There we go. What if I have 5/7 divided by 3/4? What do? Well, I again just multiply by the reciprocal. Don't freak out when you divide by a fraction. I got 5/7 times the reciprocal of 4/3, which comes out to be 20. That's 5 times 4 over 21, which is 7 times 3. Okay. Any questions about how any of those complex fractions worked out? I feel like I said it a lot, and I will write it just so you make sure you have it in your notes with a big old star or a cloud or a highlight to say when you divide by a fraction, instead of doing that, just multiply by the reciprocal. Okay. Good. No questions on that at all? I'll give a couple seconds for questions, because we're going to start throwing in some x's and we're going to start throwing in some factoring. So are there any questions before we start to do that? Questions going once? Questions going twice? Questions are gone. All right, let's take a look then at some examples that now you'll probably see in Algebra 2 setting. All right, take a look at something like this. Ready? This may seem like we're going from 0 to 60 really fast, but given what we've done in Algebra 2 this year, we should definitely be able to handle problems like this. Here we go. Ready? How about if I have 2x minus 10 all divided by 3, and I'm going to multiply that by 6x minus 24 all divided by x squared minus 9x plus 20. And I asked you to simplify that expression. Yikes. Like I said, it looks like a big jump. It looks like we just went from little A's, B's, and C's to now this big thing. But hopefully your Algebra 2 instincts are kicking in a little bit and you're like, wait a minute. Definitely some factoring going on here. We can definitely take out some GCFs. We can do some regular old trinomial factoring. This should be something that comes to your mind right away when you see something like that. So looking at this expression first, 2x minus 10, I could definitely simplify that by taking out a greatest common factor of 2. That leaves me with x minus 5 left over. The 3 is just a regular old 3. We can't really do anything with that. On the right term there, in this right, this right expression, I can go ahead and pull out a greatest common factor of 6. That leaves me now with x minus 4. And in the denominator, we can definitely factor down x squared minus 9x plus 20. And if we factor that down, we need x and x to make x squared. I need two negatives because I need to be the same sign to multiply to a positive. And that negative 9 in the middle tells me I need two negatives. And it looks like we're going to need negative 4 and negative 5. Okay? Maybe you already kind of see what's coming now that it's broken down and factored like that. But just to actually multiply it together, what I would do is I would multiply the numerator and multiply the denominator. You can skip this step if you feel comfortable doing so, but definitely the first time I really want to write it out for you. I would do in the numerator 2 times 6 is 12. I would also have a factor of x minus 5 in the numerator and a factor of x minus 4 in the numerator. In the denominator, I would have a factor of 3. I would also have a factor of x minus 4, and I'd have a factor of x minus 5. And now, hopefully, you're looking at the numerator and denominator and thinking to yourself, ooh, whoa, I can go ahead and cancel out. And absolutely you can. A factor of x minus 5 over x minus 5 will divide out, because that just equals 1, any number divided by itself. X minus 4 divided by x minus 4 goes away. So you're left with that this whole thing simplifies to 12 divided by 3, which is 4. Holy cow, that big whole mess simplifies down to just regular old 4. Any questions, comments, concerns about that at all? All right, let's take a look at another one. Okay, what if I ask you to simplify this? We got x to the third minus 7x squared, all divided by 2x squared minus 18x plus 28. And then let's multiply that by 2 over x. Okay? How do we actually simplify an expression like that? Well, again, your Algebra 2 brains should be churning along a little bit here and thinking to yourself, factoring, for sure. In the numerator, we could take out a greatest common factor of x squared from both of those things and rewrite this now as x squared times x minus 7. In the denominator, before I even break that down with trinomial factoring, I can take out a greatest common factor of 2, leaving me with x squared minus 9x plus 14. And we'll get back to that in a minute. Times 2 over x. Right? Let's continue that up here. I can say my numerator of x squared times x minus 7. We'll keep that the same for now. Now let's go ahead and actually break down this denominator on that leftmost part. This is going to break down to x and x to make x squared. Two negatives again, and it looks like it's minus 7 and minus 2. And then times our 2 over x. Again, if anybody has questions, I'm doing this, please ask. I don't think I'm going too fast, but again, if you're getting lost, let me know. Now, before we even combine these together, hopefully you can actually visualize those cancellations in your mind. The x minus 7 and x minus 7 is going to go away. X squared divided by x, one of those x's is going to cancel out. And then even 2 divided by 2 is going to cancel out as well. Did everybody see that? Look at all that canceling and reducing. So this is really just going to break down now to just a regular old x left over in the numerator, and then an x minus 2 left over in the denominator. Does anyone have a question about that? Now, a very important, as you're thinking of questions, a very important point that I want to bring up, and this is a super common mistake that a lot of students do. I see it every year. please try to avoid it if possible. The factor of x and the factor of x minus 2, those are two very distinct things. You can't just, and a lot of students will be tempted to say, ooh, cross out the x, I get 1 over negative 2, which is negative 1/2. Not the case at all. This factor of x minus 2 is a singular piece of x minus 2. We can't just take away the x because we feel like it and then cross it out with that x. That's a mathematical mistake that's commonly referred to as cherry picking, meaning we're just taking what we want without any regard for whether or not it's true. Okay, and compare that to regular old numbers, right? I can't just separate this because there's a minus sign here. Consider if I had something like this. Ready? This is just a regular old number example. 1 plus 3 divided by 3, right? What's 1 plus 3 divided by 3? Well, that's going to be 1 plus 3 is 4. 4 divided by 3 is 1 1/3, right? 4/3. You can't just do this, cross out the 3's and say that equals 1. That's not true, right? We know that's not true. Take a look at another one, right? If I have something like this, 5 plus 7 all divided by 7, right? Good example. 5 plus 7 is 12. 12 divided by 7 is some fraction, some decimal, right? It's like almost 2, about 1 point something. 1.6-ish. It's certainly not 5, right? That doesn't make any sense. We can't just cherry pick a piece and cross it out with the piece, right? Because that's not true at all. We know that that's not true because that's not how normal numbers work, and that certainly shouldn't be how variables work. Okay? So in short, this is a singular factor of x minus 2. It is not a factor of x and a factor of negative 2. That would be if they were multiplied together. But here it's a factor of x minus 2. This is a factor of x. They are very different things, so we just have to leave it alone. All right, I wanted to make sure I specifically pointed that out. Questions about that? All right, in our last 6 minutes here, we should be able to get through 2 more examples. Let's do a couple involving division. Ready? How about something like this? What if I had x plus 3 over x squared plus 2x minus 8 all divided by x squared minus 9 over 10x plus 40? What if I had something like that? Well, again, looks intimidating. But as soon as you see that you are dividing by a fraction, again, that alarm should go off in your head and you should be like, whoa, 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 hold everything. Before we divide by a fraction, let's multiply by the reciprocal. So I'm going to rewrite this as x plus 3, before I even do anything, over x squared plus 2x minus 8 times the reciprocal, 10x plus 40 over x squared minus 9. That gets us back to our familiar multiplication territory. And I find that for a lot of students, that's a good place to be. Now we can factor everything. The top left, we can't really simplify that at all, but the bottom left, we certainly can. I still have my x plus 3 in the top left. The bottom left, x squared plus 2x minus 8, well, we can break that down to x, and it looks like we need a plus 4 and a minus 2, right? To combine to be negative 8, we need 2 different signs, and to multiply to be that 2, or to combine to be that 2 in the middle when we do our distributive property, we need x plus 4 and x minus 2. Okay? Over on the right, in the top right, I have 10x plus 40. I'm going to take out a GCF of 10, leaving me with x plus 4. In the bottom, we have a little bit of difference of 2 squares going on. We got x plus 3 and x minus 3. Don't forget about your good old difference of 2 squares. We talked about that last class when we did some of the graphing examples, so always be prepared for that. Remember, you could always view that, in case you don't want to remember it as like a separate shortcut thing, you could always view that as it's x squared plus 0x minus 9. So how can I get that 0x in the middle? I need a plus 3 and a minus 3. Anyway, now looking at all that, you can hopefully visualize all the cancellations and stuff here. The x plus 4 over x plus 4 is going to go away. X plus 3 over x plus 3 is going to go away. And it looks like this whole thing is going to be left with a 10 in the numerator and a factor of x minus 2 in the denominator and x minus 3 in the denominator. Okay? More often than not, it's going to be beneficial to you to leave everything separated as opposed to distributing together. Is it incorrect if you then multiply this together to say it's x squared, what is it going to be, minus 5x plus 6? Absolutely not. Totally correct. Totally fine. But more often than not, because you want to visualize these cancellations, because you want to visualize stuff like we talked about with graphing, like your vertical asymptotes, it's a lot easier to see that in a factored form versus when it's all multiplied together. So typically, it's going to be beneficial for you to leave your answers like this. Okay, I say typically as in typically in Algebra 2 CP. All right. Okay, very good. Let's take a look at one more example. I need a fresh sheet of paper. One more example, and then we'll call it a day. All right. How about something like this? No tears. Okay, please, no tears. Here we go. How about 4 divided by x squared minus 3x minus 18? And then we're going to take that and divide all of that by 2x minus 10 over x squared minus 2x minus 15. Okay? What we have here is a very scary looking problem. I think it's a problem that math people try to present to students to scare them, but there's no reason to be scared of this particular problem. What we have here looks complicated, but it's really just a fraction divided by a fraction. So what I'm going to do is I'm going to multiply by the reciprocal. I'm not going to cry. I'm going to multiply by the reciprocal. So I'm going to start by rewriting this as our fraction in the numerator, 4 over x squared minus 3x minus 18. And I'm going to multiply by the reciprocal of this. That's x squared minus 2x minus 15 over 2x minus 10. And in one fell swoop, this just went, in my opinion, this went from a very scary problem to a problem that we're pretty comfortable with, that we should be able to factor and cancel a bunch of stuff out. Let's actually do that right now. In this term here, I have my 4 over. I'm going to go ahead and cancel, or sorry, not cancel. I'm going to go ahead and factor. I need x and x to make x squared. It looks like I need 1 positive and 1 negative. And it looks like factors of 18, that's going to combine to that negative 3. 9 and 2 doesn't work. It looks like we got to stick with 6 and 3. Minus 6 plus 3. Okay? Times. Let's take a look at this side. I have x squared minus 2x minus 15. Should be able to factor that down to x and x. We need 1 plus, 1 minus, and I think minus 5 and plus 3 gets the job done. And last but not least, we could take out a GCF in that bottom right there, pull out a common factor of 2, and you're left with x minus 5. Again, this should be like a moment where you're like, ooh, you know how you get that tingly math feeling when you know you're doing a problem right and you're on the right track and the numbers start to line up and you're like, wow, I feel intelligent. That's exactly what should happen right now. We see x plus 3 over x plus 3 is going to go away. X minus 5 over x minus 5 is going to go away. I am left with 4 over 2 times x minus 6. And what I can now do is reduce by a factor of 2. 4 divided by 2 is 2. So this would all reduce down to 2 over x minus 6. Okie doke. Whew. Fun stuff. Does anybody have any questions, comments, or concerns about how we worked with complex fractions or just working with 2 fractions multiplied by each other containing variables or not, and 2 fractions divided by each other containing variables or not? Any questions on anything we've done today? Going once. Going twice. Sean coming in with the good old nope, no questions. Fantastic. Well, thank you guys. I appreciate it. A couple things. Remember that I will post some practice problems today for you to work on that will be posted on Google Classroom along with the answer key. Please give them a shot. It's on all the simplifying stuff. Very, very important skills to have going forward into next week. So I highly recommend you give that a shot. It's not graded, but the answers are provided. You can check your work, all that fun stuff. Make sure to check in with Miss Mao's office hours or my own, either way. But we're both here if you need us, so please make sure to check in if you do. That progress assessment is due tonight, so make sure you get it to me by the end of the day today. It's only 4 problems, so it shouldn't be too bad. And if you do have any other questions or concerns, please make sure to reach out. All right. I will not see you tomorrow. So have a great weekend, and I will see you on Monday. Thank you, everyone, for your attention. Have a great day.